Hi, so we're finally done building LiveOS, which is the AI-powered brain that I was building, AI-powered second brain. I'm gonna go through the system, just show you the most interesting aspects first before I go into the actual nitty-gritties. So if you're interested in the nitty-gritties, you can stick around for that portion. But yeah, so the most interesting aspects first. You might already be familiar with the interface, just a very simple thing. So first off, I'll show you the notes. So the way it works is it goes through, you provide your notes, the notes are ingested, then you can chat with the system, and then it uses your notes to answer the questions, right? Okay, so over here you can see so many notes because these are notes that are used for the benchmarking process. They are notes from Hotspot QA. So we have the filters here, all saved, ingesting fields. So the differences are failed means you tried ingesting and it failed. Ingesting means it's currently in the ingestion process. Saved is just a note you save by the ingest. Maybe you want to just save some notes and not have them ingested into the system. Ingested is all the notes that are ingested successfully and all just shows you every single thing. And you can also search those. So it shows you all the notes that have the specific your search query in it. So I think I should see Scott Derrickson. Yeah, Scott Derrickson here. Okay, and obviously you can edit, it, review. Yeah. So next is after you're done ingesting, your information is saved into a graphical representation. Right? So this is the knowledge graph we have for the hotspot QA note we ingested. So you can go through, you move using the WSD and QE keys, and you click and drag to basically move the camera around. So click and drag, we are moving the camera around, and then we can move to the 3D space. You can see the nodes. So Soviet statesman was this, Bob Odenkirk. Odenkirk. You can click on a node to see the information about it, right? We also have community nodes. I think this should be a community. No, there's an event. Okay, let me just look for a node with a lot of connections. I think that would be a community. I think this is a, no, wait, hold on. I'm trying to find a community node. Usually the pink ones are, I think I saw a pink one here. There's an event. Hmm, the communities. Communities. Was this? Teen Titans. This an organization. Organization. Should be a movie or like a series. But anyway, it's a fictional superhero team. Okay, I guess they are an organization, right? Okay, no problem. I can't seem to find a community, which is interesting. Well, I'll show you what the community looks like in a second. Okay, so the graph is generated, and then you have the interface. So over here, you can ask the system any question about your knowledge base, right? I think right now I'm using local model, so it's going to be a bit slow. So I'll go into that in a bit. Over here, you have the knowledge bases. So you can create a new knowledge base. So basically separation of knowledge, right? You can have one for work, you can have one for school, you can have one for anything at all, right? Maybe you own a business. You can have one dedicated for your business knowledge, your business documents. So let's switch to work. And when we go into the notes, you notice the notes are different. So these are like my personal work reports. I'm not going to show them. And then you have the graph. Okay, so yes, this is a community. So yeah, that's what the community looks like. I'm not going to open them. And also there's just 4 notes worth of graph. 4 notes worth of data. So you notice there's not a lot of there are not a lot of nodes available. But yeah, I'm not gonna open them because this is work information. Mm. Oh, I mean, there are certain points I could show, but yeah. So we have the chat interface here and settings. Yeah. So for settings, you can switch your provider. Um, we have Adam Studio, Olama, Gemini, OpenAI, Anthropic, and Hugging Face, right? So if you switch to Gemini, for instance, you have to set your environment variables in the. You have to put your API key in the environment variables in your workspace, right? So yeah, you set up the project directory, put the environment variables in all, and then you can just switch your providers here. It might be easier to just allow you to put the API key in the from the front end directly, but well, think about that. So when you switch your provider, you have to switch the model name as well. And you can change the model for ingestion, you can change the model for chats. Right. So here, I think that's pretty much everything, right? Yeah. So going back to default. Okay, cool. So that's basically everything for the interesting parts, I guess. Right. I think this is the most interesting feature where you can just first through your knowledge base, the graphical representation of your knowledge base, right? Cool. So now going into the technical aspects here. This is the repository. I'm going to be making this part. So as soon as I end this video, this repository is going to be public. I might be making a few more changes here and there, but yeah, I think for the most part it's done. So if you want to find the repository, this is the URL. It will be in the video description as well. So this is the README. Uh, I mean, you can read it for yourself. You are going through everything, right? Mm. So pipeline. Yeah, let me talk about the pipeline. So we actually process multimedia. So there is PDF processing, audio processing. So you can talk, right? So your whatever you say will be transcribed, and then it'll add it to the notes. Right? It will also append it to the notes. Can add images. The image description will be generated, and then that will also be added to the notes. PDF, audio, images, PDF. Where the next cell as well. I've actually not tested this one myself personally. These are the three I've tested and I know are working. So you can feel free to test this out and let me know if it breaks. Okay, so LLM extraction, it creates the entities and it creates the relationships. Yeah, I mean, concepts, they are still entities at the end of the day because there's still just going to be one node, and they have the isolated context for every single node, which was shown in the yeah. Okay, so let me open the node. So you notice context, right? It's just one context for this node. With a node like Teen Titans, let me go back. Search Teen Titans. Yeah, with a node like this, you notice the context was a lot. There's a lot of isolated context for Teen Titan. So yeah, generates gets the isolated context from the nodes and then populates the. So we have graph rights, vector indexing. So the indexer we're using. Oh, actually, I think I can even show you that as well. Quen 3, yes. So we're using Quen 3 embedding and Quen 3 re-ranker for the system. Right. So the embedding is generated, indexing, embedding is absence, full text indexing. So yeah, basically what we're doing is we are using the embedding, we're using vector search, we're using a hybrid search approach for the retrieval process, for the chat process. So when you ask the system a question, it goes through the hybrid search to try and find all the relevant information and then gives that to the LLM for the LLM to answer it. So the hybrid search is vector search, BM25, and entity search. Exactly. So if your question has certain entities in it, for instance, what was my work in really okay, let me actually use the let me use the test data. Right? So if I ask the question like, who is Scott Derrickson? For Derrickson, the LLM will analyze the question and then take out the entities. So it will identify the entity Scott Derrickson. Then it will do an entity. So hybrid search, it will check, is there any entity in our knowledge base called Scott Derrickson? If there is, get it and get all the information about that entity. Then it does vector search, finds all the similar things in relation to the question. So let's say the question was something like, what movie did Scott Derrickson act in, right? So it knows that, okay, so it will embed the question. It knows that, okay, movie, try and find anything similar to movie. So it could get film, it could get series, anything like that. Then the BM25. So basically the so for that aspect, the way it works is it looks at the question, it takes the relevant portions. It's also kind of like entity search. With this one, it's just it goes through the entire knowledge base, finds, okay, so it takes a search query, it takes like a word, and then goes through the entire knowledge base to find where it can get that specific word within the entire knowledge base. If it finds a match, it gets that entity, that information, and adds it to the search results. So the hybrid search gets a whole array of search results. Then it goes to the re-ranker. Okay. I'll talk about the community detection. Then it goes to the re-ranker, and then the re-ranker ranks the results according to the most relevant to the specific query. And I think it's the top 10, given a specific threshold. You can change the threshold if you want to. The top 10 that actually reach the LLM for the LLM to use in answering the question. Cool. Okay, so back to the ingestion pipeline, the flow. We have the multimedia node, multimedia processing, the LLM extracts all the entities, relationships, and all that. It is then written into the system. Okay, well, no, not yet. It is the vector, the embeddings are generated, right? Then everything is written into the system. We have the full indexing as well in timestamps, and then we have community detection. So for the community detection, what happens is when the ingestion process completes, it waits for about 5 minutes. I think that was the time I said. It waits for 5 minutes, and then after 5 minutes, it automatically starts the community detection run. It uses laden, right? If another ingestion happens before the 5 minutes is up, the 5 minute timer is reset. If an ingestion happens while community detection is occurring, the community detection stops for the ingestion to finish, right? Okay. So these are just some stats. Then we have the retrieval. So I've already spoken about the retrieval pipeline. Well, I spoke about the hybrid search aspect. So for the actual retrieval pipeline, what happens is it's a iterative loop. Oh my god. Up to 10 iterations. And basically what happens is it takes the original question and then it tries to find the relevant answers for that. If it doesn't find enough information, it will do that whole process again. It will so no no not it will do as well. Okay, so what happens is it will ask what information am I missing to actually answer the question in full. Then it will so okay, so let me give an example. So let's say the question was what movie did Scott Derrick, okay, no, let me use an actual example. One of the actual questions. Mm. Are Scott Derrickson and Ed Wood of the same nationality, right? So the LLM will ask, what information do I need to answer this question? So what is the first thing needs to know what is the nationality of Scott Derrickson? Then the process will run. It When it finishes, it will have its answer for that specific iteration. Scott Derrickson is an American. Then what other information do I need to answer the question? Okay, next I need to know what the nationality of Ed Wood is. And so ask the question, what is the nationality of Ed Wood? And then it goes to the hybrid search, gets the results, and then answers. Ed Wood is an American. And it goes. What other information do I need to answer this question? I don't need any other information because I know the information that's I have all the information I need. So I can answer the question now. Then it answers the question. That's basically the iterative loop. All right. So infrastructure, we use TypeSense, Postgres, KWell, Rust FS. We're actually using MinIO, but I mean, there was some recent news about it's MinIO. About MinIO, basically no longer, the community edition no longer being supported, so we switched to Rust FS. We have killed runs as well. Front end is just next year's 16, Tailwind, yeah. So for the, okay, yeah. So the LLM models, right? Right now, like I was saying, it's LM Studio, Olama, OpenAI, Gemini, Anthropic, and Hugging Face. The only thing is, yes. So we tested the system with the Gemini 3.1 Flash, Gemini 3 4B, and then Gemini 4 E4B, right? When we tested the system, these were the results we got. So you notice that Gemma 4 E4B local was on par with um, Gemini 3.1 Flash, which is like incredible because Gemini 3.1 Flash is like a very powerful model, right? And for a local model like Gemma 4 E4B to be able to be on par with Gemini 3.1 Flash is incredible. Now, Gemma 3 4B was not very good, and I think that's mainly because, well, I mean, yeah, it's an older model, right? But it also doesn't have thinking capability. I think the main reason Gemma 4 E4B was able to do far better than Gemma 3 is because of the thinking capability of Gemma 4. Okay. And also it took them it took the longest amount of time because I mean it has to think as well. Anyway, moving forward. So I'm actually going to show you the results right now. Results from testing. I mean, those results are there, but just want to show you. uh, Wait, oh, there we are. Results. Tab optimization. So the log files are also here. You can check the log files yourself and see how everything went. So ingestion.log, it's basically the entire log, right? So every single thing that happened during the ingestion process, you find it here from start to finish. Yeah, it's a very big file. um, and then retrieval log. So every single thing that happened in retrieval. It's also a very big file. I do view raw. Mm, yeah, loaded. Okay, yeah. So you notice. Okay, so exactly the example I gave was consideration and a root of the same nationality, right? So queries, consideration nationality and root nationality. Interesting. It actually asks both. Well, it's put both of them together in one search term instead of splitting it into two. But well, no problem. It works. It's so fast it worked. It's not an issue. So I extracted entities, Scott Derrickson and Ed Wood. So entity match Scott Derrickson, right? No name Scott Derrickson. So it found Scott Derrickson. Scott Derrickson is an invalid directed blah 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 blah. Blah. Born this aha, there it is, an American direct. Cool. And then we have vector match and all the rest. Okay. So let's go back. So like I said, I wanted to show you the results here. Gamma 4 E4B results. So this was the final run after I basically optimized a few things and fixed a few things here and there. And we had exact match of 62%. Crazy. And then fuzzy match of 81%, right? Using Gemma 4 E4B. Like, wow. Okay. Retrieval precision 36, retrieval recall 61, F1 45, average response time 231,000 milliseconds. Cool. Right. So you see the specific answers where this and this of the same nationality, yes. And actually, the results should have been a little bit. Yes, I didn't want to tamper with anything. So in 1950, I don't remember the specific thing, but I think no, 1960. There's a specific answer. Here, yes, this is it. So here, over here, the expected answer was 1969 until 1974. And then it actually got it correct, 1969, 1974. The only problem is, you see, so this character over here is actually the hyphen dash, is a dash character. So what it actually did was it did, anyway, I can type, it did 1969 dash, whoops, 1974, right? And this is actually correct, but it doesn't match exactly, and I mean it's using a weird character. So it just marked this as a wrong answer. But anyway, so yeah, these are the results. You can go through everything yourself, see how it went, and yeah, I mean there are some optimizations that could still be done, I guess. So that's basically it. So that's basically it for the system. Everything is done now. You have the opportunity to like I said, I'm making the repository live, so you have the opportunity to just get everything tested for. One thing I should do actually. So these are the models I'm using. Give me a second. Okay. Second models. So we are using Florence too large for the image description generation. We could use Shema 4 itself for that as well, but Florence too large is actually quite fast given uh given everything here, right? Like it works, it's faster, it's more optimized for the OCR launches, and then it's also like it's a small model and then it works fast as well. So yeah, we could use Yama 4 for that, but figured using Florence 2 would be the better approach, right? We have Quentry re-ranker 0.6b for the re-ranking, and then we have Whisper to Turbo for the encryption. We're using LM Studio. We're using Olama initially, but now we're using LM Studio the for Gemma 4 and Quentry embedding. Yeah. Right. Okay. So I think that's basically everything. And yeah, if you have any ideas on how we could improve the system, if I mean, it's the repository is going to be public, right? So you can go clone the repository and just go wild. All right. So thanks for tuning in and have fun, I guess.